guys, welcome in this new video. In this video we will be discussing about the greedy algorithms. So in this video we will be discussing that what greedy algorithms are, when to use them, and what are the advantages and their disadvantages, and a few small two problems which will make your understanding clearer. So before starting the video I would like to tell that previous to this video I made about insertion sort, uh, so do check that out as well, and you can also see the playlist created by me for the step-by-step videos through the I button. So with no further delay, let's get started. So first of all we will see that what greedy algorithms actually are. Okay, so greedy algorithms are the technique, like the greedy algorithm is a name given to a technique that actually optimizes a solution by seeing near elements or the near data to actually take its decision and not the entire data. Okay, and it is similar to the word greedy in the English vocabulary as well. That's why it is known as greedy algorithm. Okay, so what it does is, for giving a solution for an entire data, it will not check for the entire data but only some few values in ahead. Okay, and due to this it will not always give us the best global solution, optimal global solution, but it should be considered sometimes, because generally the solution that it gives are approximately optimal. Okay, and one such problem like the TSP, that is the traveling salesman problem, can also be solved with this greedy algorithm. We will discuss about traveling salesman problem in some later video, but for that problem this greedy algorithm approximately gives the optimal solution, and this sometimes actually reduces the time complexity for any algorithm. Okay, so let's say some algorithm can be solved in exponential time. Okay, in an exponential time, so it will reduce it to the polynomial time to to solve in polynomial time. Okay, so this was a brief about greedy algorithms. So we generally use it when we are looking for immediate benefit from a situation in the solution. Okay, right, like I told that it actually makes the decision that looks right at the particular moment, and what it thinks will give the best solution, so it gives that as the solution. Okay, now getting to the pseudocode of it, which is actually generally the case in all algorithms, like all the greedy solutions which we follow. Firstly we will initialize an empty result list or array, whatever you can take. Then we will just check for the every element and put it in a variable, and then check whether that value or the result is giving a feasible output or not. If it is feasible, then we will just append into the result, and we will follow this loop until we have traversed all the array or the list elements, and at last we will return the result. Okay, so why to choose the greedy approach? Basically I explained you why we use greedy approach just now. So it is actually suitable for optimization, so that's why we use it as well, and it is actually proved to achieve most feasible solution immediately, so it is used. So basically two things are there, see, greedy choice property, and one more is this optimal substructure. Okay, so we generally target those problems that are having some sub problems that can be solved greedily, and one thing we can say is that optimal substructure is also there. Okay, so this in this greedy choice property, this property just says that the globally optimal solution can be obtained by making a locally optimal solution, that is the greedy one. Okay, so the choice made by greedy algorithm may depend on earlier choices but not on the future, as I just explained you above. So it iteratively makes one greedy choice after another and reduces the given problem to a smaller one, as I told you. So one optimal substructure is also there, that a problem exhibits optimal structure if an optimal solution to the problem contains optimal solutions to the sub problem. So basically what it is saying that, um, let's say you have a bigger problem and it can be optimally solved if we solve its sub problems optimally. So it is a kind of a divide and conquer thing, but in the divide and conquer, when the sub problems are there, so we solve when if we solve those sub problems optimally in a best time complexity, then we this optimal substructure problem tells that when we actually merge those sub problems into the original problem, then it will give us the optimal answer. Okay. mm, so that means that we can solve problems and build up the solutions to solve larger problems. Okay, so yeah, as I told you. So yeah, one more thing to note it is that greedy algorithms will not always give the best solution, but yeah, it makes maximum times it gives locally optimal choices. But yeah, they work, and we must know when to apply these, and this will come by practice only. So like, see, here they have given like when we actually use greedy algorithms, so you can actually refer this one. So when there is order lists of resources, so like we have to calculate, we are given profit, cost, value, or we have to actually find maximum profit, maximum value, this kind of thing, then we use greedy algorithms. For example, in fractional knapsack problem, the maximum value per weight is taken first according to available capacity. So this problem, fractional knapsack problem, we will discuss in some another video. So don't be don't be afraid of such jargon word. Yeah. And application of greedy algorithm, as I told that it is used to find optimal solution, and finding close to the optimal solution for NP-hard problem like traveling salesman problem. So we will discuss about this activity selection problem here, and to give you a better understanding. And let's just see on the advantages and disadvantages now. So greedy approach is easy to implement, typically have less time complexities, can be used for optimization purpose or finding close to optimization in case of NP-hard problems. NP-hard problems are basically those problems that cannot be solved in polynomial time. Okay, in a blunt way, I have explained you what NP-hard is and what are the disadvantages. So one disadvantage is that the local optimal solution may not always be global optimal, and yeah, so just hope let's hop into this activity selection problem, that is the greedy that we will solve actually with the greedy algorithm. So basically what they are telling is that we are given n activities, and they are given with their start and finish time. So how to like select a maximum number of activities that can be performed by a single person, assuming that a person can only work on a single activity at a time. So I'll just explain you via this image. So you can see that initially if we are given these array elements with pairs, array of array is given. So 5 9, that this first activity is starting at 5, then will end at 9, then start at 1, then end at 2, then start at 3, end at 4, start at 0, end at 6, start at 5, end at 7, start at 8, and end at 9. So we, for finding the solution, we have to actually first sort them according to their finish time. Okay, we have to sort this array according to the finish time, because the faster the finish time, like when the finish time is much faster, that it has been finished in less time. Okay, so just get the essence of what I am trying to say. So basically sort the array according to finish time. So this we have to do. Then we have to check whether, like, just sort and print the first sub array. Okay, array of array. So array of array is given, so first sub array we have to just print it. Now we have to check while traversing other array sub arrays that the start time is greater than the previous finishing time or not, greater than or equal to. And if it is less, then we will just hop on to the next sub array, otherwise we will print it. Okay, so after this one, as 3 is greater than 2, so we will just print that one as well. 3 4 after 1 2, and after that, as 0 is less than 4 here, so we will just hop on to the next one. And after that we will check whether 5 is greater than equal to 4 or not. Yes, it is, so we will print 5 7. Similarly we will check 8 and 7, so 8 is greater than equal to 7, so we will print 8 and 9. And now, as 5 here is less than 9, so we will not print it, and we have our solution as 1 2 3 4, then 5 7, and then at last 8 9. So this is our solution from the greedy problem. One more problem is that for this Egyptian fraction method, which tells that we every positive fraction can be represented as a sum of unit fractions. So a fraction is a unit fraction if numerator is 1 and denominator is a positive integer. So if an example, we can tell that if we have 1 by 3 as a unit fraction, so we can actually use this to represent a positive fraction. Okay, this was actually used by ancient Egyptians. So this method is called, like, this problem is the Egyptian fraction problem, and it can be solved using greedy approach as well. And in this, we just what we do is, if we are given a fraction, see, if we are given a fraction, then we will just um, swap the numerator and denominator, find the result, then we will just swap again the numerator and denominator, and then subtract from the original fraction, and we will get our result. So this one, and 1 by 3 and 4 by 42 are is our answer. Okay, so like this, one thing is this one. So you can actually see this problem as well. And I think our video is getting much longer, so yeah, have a good day and keep learning and keep watching till the next video.
Untitled.